Welcome back, class. I'm Mr. Teacher with the SAT Math video guide, and I kind of sounded a little off last episode or video. I wasn't feeling that well, but anyways, today we will be starting on number 11, so which has this inequality equation right over here. So it asks, which of the following represents all values of x that satisfy the inequality above? Well, to figure that out now, we need to solve for x. So let's simplify this. Let's add 5 to both sides to get rid of the 5. And so you get minus 1 plus 5 equals 4 is less than or equal to 4x. And if we divide both sides by 4, we will get 1 is less than or equal to x. Or you could also say x is greater than or equal to 1. That's also the same thing. And the only answer choice that shows that is A. Now, let's quickly touch on a point on number lines here. So, let's draw a makeshift one over here. Well, not a makeshift one. It's a proper one. So, this is 0, 1, 2, 3, 1, 2, 3. Now, if the inequality was greater than or less than, let's say it was x is less than 1, then you will find the value of 1. Actually, no, let's not use 1. Let's use negative 1. So you would find the value of negative 1, and the scale is to 1 per line. So this is negative 1, and then you would draw a circle around it. And don't fill it in, just a circle. And since x is anything less than negative 1, you draw an arrow to the left side of it. But this is x is greater than or equal to 1, so it'll look something like this. You find the 1, and then you completely fill it in. That's what happens when it's greater than or equal to or less than or equal to. And x is anything greater than that or equal to that, so you extend the line this way. And the only one that looks like this, at least this part of it, is choice A. So that is your correct answer. Oh, I already wrote A. I don't know when I wrote A, honestly, so that's very awkward pause. Number 12 is a circle, which looks like so. And there's a rectangle here. And there's another rectangle here. And this is a horrible circle. You can assume that's a proper rectangle. So now we label it Q, R, Y, Z, S, T, W, X. So it asks, in the figure above, rectangles PQRS and WXYZ each have perimeter 12 and are inscribed in the circles. How many other rectangles with perimeter 12 can be inscribed in the circles? So it's actually pretty funny because in this problem, what the perimeter is of the rectangles doesn't matter at all. It's just there to confuse you all the way to oblivion, because you're just going to be sitting around thinking, what am I going to do with this perimeter? So, as you know with a circle, maybe not this circle, but with any other circle, any regular circle, it's symmetrical. So, a triangle that has a perimeter of 9, which is this triangle, is going to be can be fitted in any way possible, whether you rotate it or not. If you rotate it, the perimeter is still going to stay the same because of a circle being symmetrical on either side. And you could prove that by the radius. Radius, let's say this is 5. This is also 5. And this is also 5. It's all 5. So it's symmetrical. So in reality, infinity number of rectangles is going to fit inside the circle. And so infinity is definitely more than 4. So that's choice E. That's the correct answer. Now to number 13, which asks, if n is a positive integer and 2 to the power n plus 2 to the power n plus 1 is equal to k, then what is 2 to the power of n plus 2 in terms of k? So here, since the answer choices also just involve k, let's pick a number for n. Let's say n equals equals 2. No, let's say n equals 3. So we get 2 to the nth plus 2 to the nth plus 1 is going to be equal to k. Therefore, when we plug 3 into n, 2 cubed, 2 to the third power, not cubed, well, maybe, yes, 2 cubed, plus 2 cubed plus another power is equal to k. So this is equal to 2 to the fourth. So 2 to the third is 8. 2 to the fourth is 16. This is equal to k. Therefore, k is equal to 24. So now we need to figure out what 2 to the power of n plus 2 is, which is 2 to the power of 3 plus 2, which is 2 to the fifth power. So we need to figure out what this is equal to. Well, let's just, figure it out. 2 fourths is 16. 16 times 2 is equal to 32. Now, what is 32 in terms of k? Then we look at the answer choices. So let's start with C, as they most probably are going to be in order. Actually, I know they're going to be in order, because that's the rule of the SAT. Whether it's greater to less or less to greater, the answers are always going to be in order. So let's start with C, 2k. Well, 2 times 24 is 48. 48 does not equal to 32. So C is not the correct answer, and that's 48 is too big. So let's take a chance and go to B. B is 4k divided by 3. What is 4 times 24? Well, let's solve that right now. 16, 96. 96. So 96 divided by 3. 90 divided by 3 is 30. And 6 divided by 3 is 2. 32. And 32 is equal to 32, which is what we got in this, 2 to the fifth power, or not this, this over here. And so we know that our correct answer is choice B. And now we'll go to number 14. Oh, no, I didn't want that. Number 14, and there's a triangle here. And it looks like this. Triangle ABC with degrees x degrees, y degrees, and z degrees. So, note figure not drawn to scale. We'll always remember that with any figure, but anyways, the triangle above is isosceles, and AB is greater than AC. Which of the following must be false? Now, we know it's isosceles, so if AB is greater than AC, we know that BC can be equal to AB. Or it could also be BC is equal to AC, but we're not sure about that. But we don't really need to know that now. So let's try and figure out each answer choice. So it asks, AB is equal to BC. That can be true, because that is one of the conditions over here. So that's not the correct answer. We need to find which one must, by all means possible, be false. So let's look at B. BC is equal to AC. So BC can equal AC over here. So it is true. It's not false at all. It's true. So that is also a wrong answer. We're getting kind of confused here because you generally don't mark a correct answer as wrong. But x equals to y. If we know this can equal to this, or this can equal to this. So can x equal to y? Well, sure. Line BC is equal to line AC. So that's correct. Therefore, no, that's not false. Therefore, it's wrong. X equals to z. That could be possible. Of course, x is equal to z. So since that's correct and not false, it's wrong. This is getting very confusing with the terms. Y equals to z. Well, we know that y cannot equal to z at all because AB is greater than AC. So, AB cannot equal to AC no matter what circumstance. It's already given, it's greater. So due to an isosceles rule, the isosceles rule, if these two are the same, then these two are also the same. Since AB is not the same as AC, Y cannot equal Z, and therefore our correct answer is E, the only choice that is false. Now we'll move on to number 15. And, oh, that's from the last video, I apologize. Number 15, which is a pie chart, and big pie chart, and food. I'll just write the first letters, 30%, then miscellaneous, 10%, then hotel room. My pie charts are always horrible. Let's keep that in mind. 20%. And transportation is 40%. So, the graph above shows the distribution of Tom's $240 trip expenses. So this entire pie chart is literally equal to $240. The amount Tom paid for the hotel room was only part of the total hotel room cost, because he shared the cost of the room equally with 3 other people. So what was the total cost of the hotel room? Well, the hotel room is equal to 20% of his expenses. Therefore, it is 20% of $240. When you multiply 20%, which is 0.20, with 240, you will get, I believe, give me a second here, 48. So that's the amount he paid for the hotel room, but he shared this equally with 3 other people. So since 4 people paid the same amount, you need to multiply 48 by 4, and you will get 192. So your correct answer is choice D. So now we'll move on to the next problem, the final problem, in fact, and we will be able to end off the video. So number 16, which says, on a square game board that is divided into n rows of n squares each, n rows of n squares each, k of these squares lie along the boundary of the game board. Which of the following is a possible value for k? So let's draw a game board. So let's draw a 3x3 game board, because when there are 3 rows, like so, there are also 3 spaces in each one. So it looks like this. Sort of. Yeah, that's exactly how it looks like. So the length is n, the width is also n, and the amount of squares inside is n times n, and each row has n. So we can translate this, because the length is 3, the width is 3, the amount of squares is 3 times 3, and the number of squares in each row is 3. This is very repetitive. So we need to find which of the following is a possible value for k, and k of the squares lie along the boundary. So along the boundary means this one, 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 and this one. So there are 8 squares, so 8k. K, well, rather, k in this case is equal to 8. So we know it can be a multiple, it's an even number. That's all we know up till now. We can't assume anything yet. So let's look at something bigger, or rather something smaller, and let's first look at that. Let's look at a 2x2 game board, although that's never going to happen, but this will also prove our point. So the number of squares along the boundary wall is every single square, because there is no middle area that is not touching the border. So there are 4. In this case, k is equal to 4. So we know that these can be a multiple of 4. And now, just to make sure, we're going to do a 4x4 game board. So 1, 2, 3, 4. This is the best I could do for a game board at the moment. 2, 3, and okay. Okay, no, I got this. 4, and then another row here. 2, 3, 4. So it looks very horrible, but we just need to count the squares on the boundary. So there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. So in this case, k equals to 12. So now we're completely positively sure that k is a multiple of 4. So when you look at the answer choices, 10 is not a multiple of 4, 25 is not a multiple of 4, 34 is not a multiple of 4, 42 is not, but 52 is. It's 44, 48, 52. So that's the only answer choice possible, and that's choice E. So there's the end of section 8 and the end of test 2. So let's pop a confetti cannon, have a party. However, we still have test 3 to 10 left. So hopefully stay tuned for even more videos. They're coming really soon. I hope this helped you with your math prep and SAT prep. And I will see you in the next video.